Hello, everybody, and welcome back to week 4 of environmental concerns. Today, we're going to be talking about ecological footprints, but before we get into that, there's a couple quick notes that I want to talk about first. So, first off, I just want to go over quickly assignment number 2 here, just the kind of things I'll be looking for. So, it will be 1 to 2 pages long between that length. If you make it much longer, like if it's 2.5 pages, not the end of the world, but try and keep it within that limit. If it's shorter than that, then that's going to obviously not be great either. I'm asking that you include footnotes and a bibliography for it, and it will be due Friday, February 11th at midnight. There are 3 different groups that you can choose from. You don't have to do all 3 of them. You only have to choose one. So either an individual, a business, or a country. If you're choosing an individual, such as yourself, you're looking at stuff such as how does an individual fight climate change. If you're looking at a business, you can choose a fictional business if you want to make it up entirely, or you can choose an actual business that exists in real life, such as Nike, Maple Leaf Foods, Google, whatever you want. And you can look at stuff like how if they've initiated any sort of green initiatives, and if so, what are they? Finally, you can look at a country and if they have any sort of implementations in that regard. The assignment suggests some questions to be answered, such as what are realistic things the group that you've chosen has implemented or could implement? How much of an impact do these implementations make? And do you think they're doing enough? You don't have to limit yourself to just those questions, however. If there's some sort of thread that you find and you want to tug on that to try and find some more information for your research subject, by all means feel free to do that as well. So these are essentially what a footnote is if you are curious. The presentation itself will be provided on Blackboard for you to access, so you can actually click on the link provided in this slide to access more detail on how footnotes should be constructed. Because footnotes will differ depending on the source that you're using. As you can see from this quick little snip that I got right here, if you've got a book or you got an article in a journal, the way that the footnote will look will differ. I'm assuming most of you will probably have some sort of internet source or website that you'll be using. So that this website that I provided here at uregina.ca will also show you how to make a footnote for websites. Please use this as your reference. A couple other quick things that I wanted to go over. Another reminder that assignment number 1 on the carbon footprint is due tonight at midnight, so February 4th, tonight. Another quick reminder that assignment 2, the one I just discussed, will be February 11th at midnight. I also made a fun little escape room, virtual escape room rather, for this week's topic of the ecological footprint. It will be provided as a link in the week 4 folder. If you do finish the escape room, there will be a quick little section where you can put in your name and your email address. I'll be able to see that. And if you do complete it, I'll email out a professionally made championship belt, which was made by me in Microsoft Paint. So professional might be a bit of a stretch. There's also a worksheet provided in the week 4 folder. Again, you do not have to complete this for marks or anything, but it can be an excellent study aid for the upcoming midterm. And finally, there will be office hours again with yours truly on February 7th. That's the Monday coming up. The hours will be between 7 o'clock and 9 o'clock p.m. If you request or want to meet with me for a 20-minute block, there is a sign-up document in the weekly learning folder. Just find that, throw in your name and the time slot you want, and we're all good to go. I think that covers everything, so without further ado, let's get into the actual topic, which is ecological footprint. There it is, ecological footprint. So there are 2 main topics that we're going to be covering today, the environmental performance indicator and the ecological footprint. So the ecological footprint, the ecological performance indicator is basically something that was started in 2002 by outside groups that wanted to kind of categorize or grade every country on how they're doing to protect the environment. I'm actually going to just take my face off of here for now, just so that we can actually read everything. So our global footprint is directly impacted by how the world's countries prioritize its environmental issues. This has created a need to organize and evaluate each country and make everyone aware of the level they are at overall. The Environmental Performance Index ranks how well countries perform on high priority environmental issues in two broad policy areas: the protection of human health from environmental harm, and then the protection of ecosystems from humans, but also from other sources, just for like other environmental sources. The EPI recognizes that environmental studies matter, so reliable data reduces uncertainty with respect to the scale of an issue and allows policymakers to move forward with solutions. Global data can also be useful in highlighting gaps in our knowledge, which is important because, as the saying goes, you don't know what you don't know. This is done so countries are more aware of how they are making efforts to be environmentally friendly compared to other countries. It also is done to highlight where countries could do better overall. As I said, it was initiated in 2002, and by 2014, the EPI had ranked Canada at 24th out of 178 countries, which isn't too shabby, but there is definitely room for improvement. This ranking was up 2.6% from our original 2002 rank, which not a big improvement over, the 12 years. Our current EPI ranking is 20th as of 2020, and the top winner as of 2020 is Denmark, with Luxembourg, Switzerland, the United Kingdom, and France covering the top 5 worldwide. So the EPI uses this massive chart here to outline all the different ways that they grade our countries. In a broad sense, there's 2 policy objectives. Those are the big 2 in the middle, your ecosystem vitality and your environmental health. And those are broken down further into 11 issue categories. So stuff like biodiversity and habitat, climate change, sanitation and drinking water, air quality, and so on. And then those are further broken down into 32 indicators, such as tree cover, wastewater, CO2, lead, drinking water, sanitation, and so on and so on. The EPI score and rank these countries on their environmental performance using the most recent year of data available, as well as data from approximately a decade earlier. The state of the world is captured in the global scorecard, which is where Canada ended up ranked 20th. These results reveal current standings on a core set of environmental issues and identify where progress is or is not being made. Full results of the 2020 EPI, including the country and indicator level analysis, are available at epi.yale.edu. It's interesting to see how the world grades Canada, since they're looking at us from the outside, on each of these 32 indicators, so I do encourage everyone to take a look. I found it pretty fascinating. The ecological footprint measures the pressure for resources each person, group, or human activity places on the planet. The ecological footprint indicator tells us how much biologically productive land space a population needs in order to provide the resources being used and to absorb the waste being generated by that population. So that includes landfills as well. 1 unit of productive land space is known as 1 global hectare. In 2014, Canada's ecological footprint measure was 8.28, meaning Canadians required 8.28 global hectares per person in order to meet their demand for resources and to absorb their ecological waste. So how does that number kind of get derived? It's because, just telling you the number 8.28 doesn't really tell you a whole lot, right? As we go back to that, it says 1 unit of productive land space is known as 1 global hectare, but that's including how much space is actually needed for us. If you eat fish, that goes into the fisheries component of the productive land space. So if you eat fish, that's going to contribute to that 8.28 overall. If you have a cell phone, then the materials needed to use that would also start contributing to that. If you eat meat, so on and so on. Globally, humans are using resources faster than the Earth is capable of regenerating them. On average, the resources used in 1 year take 1.5 years to regenerate. You can already see a problem with that in the math right there. Canada's environmental capacity to regenerate resources, otherwise known as our biocapacity, in 2014 was 14.6 global hectares per person available. When you reference that to the number I gave you just shortly before, where our ecological footprint measure was 8.28 in 2014, that means that we're actually exceeding our ecological footprint with our biocapacity. That's really good for us for now. That means that our country is actually producing more than we're actually consuming. That's not all the case for every single country. And here's a quick snapshot of how Canada's ecological footprint looks. It is a little outdated, as you can see. The chart ends at 2010. But basically, Canada has been an ecological contributor since our biocapacity has remained higher than the population consumption. In fact, in 2010, Canada is one of the top 10 biocapacity-rich nations. These 10 nations contribute more than 60% of Earth's total biocapacity. Canada harbors 4% of the planet's total biocapacity, as shown in the next slide. As a note, the reason the green dashed line shown here is decreasing is mainly driven by Canada's population size. As the population increases, the capacity to support everyone decreases. So here's that biocapacity that I was talking about throughout for the entire world. You can see here that the top 10 contributors were Brazil, China, the USA, Russia, India, Canada, ourselves, Indonesia, Australia, Argentina, and Congo. The rest of the world makes up this big blue section. So as you can see, just these top 10 right here contribute a very large percentage of our biocapacity for the world. Unfortunately, the gap between our footprint and our biocapacity has narrowed each year. This means that Canadians are getting closer to consuming natural resources at a rate that is faster than our environment is able to regenerate them. So this is a factor of us consuming more than we did in the past, but also due to our increasing population size. This might be a poor example, but if you imagine a bakery that can make a cake that serves 12 people, it's fine if there's only 5 people at first. In fact, those 5 people could even indulge and have 2 pieces if they really wanted to. But as time continues and as more people start having this cake, 10 people, then 12 people, and finally getting over the amount the cake can serve and having 13, 15, 20 people, what happens? The bakery can't sustain that many anymore. And that's the kind of problem that we're starting to run into. This illustrates this chart here, the world ecological footprint by land type. It illustrates since the 1960s the increase in consumption. All the way up to around 1971-ish, we were still consuming less than what the planet can produce, which is great. But after that, we have continued to consume more and more to the point that our current population would need the production of 1.5 to almost 1.75 Earths to balance out our needs. I hope everyone also noticed how most of the land types have remained relatively consistent throughout the years. It's the carbon consumption, which has drastically ballooned and caused issues. Why do you think that is? I'm going to speak briefly on the top 3, offenders in terms of global ecological footprints. The United Arab Emirates occupies the #1 spot on that list. The ecological footprint is 10.68 gigahectares per person. The majority of resource demands come from households and their energy use. Other factors contribute to this large number. The Dubai Executive Flight Service catered to over 6,000 private jet flights in 1 year. Taxis are more popular than public transportation. They also had something called the World Project, which I also encourage you guys to take a look at because it's kind of a fascinating idea in vanity, I think, which seeks to create islands shaped like all of the world continents and has used 34 million tons of rock. Once complete, homeowners will only be able to arrive via boat or private jet. That said, the country has created a task force to understand and reduce its energy consumption because it is, as I said, the #1 spot on this list. To date, the World Project seems like it might just be a failure. The islands are eroding with the sand being used to create them slowly sinking back into the sea. Only a few of the islands themselves have had anything actually developed on them, and for the most part, they're mostly used for business parties and galas. Overall, it seems like it's a very expensive endeavor with very little to show for it at the moment. Secondly, we have Qatar with the second highest ecological footprint. It follows close behind the United Arab Emirate with a footprint of about 10.51 gigahectares per person. It is necessary to take into account the small population size of the country, however. One of the biggest contributors to this number is the amount of water consumed, followed by energy used. So, the question asked is how can residents afford to use such high levels of energy? The answer is simple. Government provides free energy for nationals and heavily subsidizes energy for everybody else. And finally, number 3 on the list is Bahrain with an ecological footprint of 10.04 gigahectares per person. This number can be explained by the heavy dependence on fossil fuels, low levels of environmental education, and just extravagant lifestyles in general. It's probably a great party country if we're being honest though. So here's the top 10, and you can see Canada does make it on the list. This was more recent than the number I was showing you previously, where Canada has 7.01 global hectares per capita. So we're ranked at number 8, which is below the United States at 8, and so on and so on. If you recall, Canada's biocapacity was 14.6 gigahectares per person. So since that number is unique to Canada due to our country's beauty in terms of forests, freshwater lakes, and more, not every country can boast a biocapacity higher than their footprint. So what that means is that if they have a biocapacity that's lower than their footprint, they are in an ecological deficit. These numbers here, the ecological footprint, do not take into account that biocapacity that I just mentioned. So the simplest way to define an ecological footprint would be to call it the impact of human activities measured in terms of the area of biologically productive land and water required to produce the goods consumed and to assimilate the wastes generated. More simply, it is the amount of the environment necessary to produce the goods and services necessary to support a particular lifestyle. So as you can see, there is 6 different types of land types. We have our fishing grounds, our built up land, cropland, grazing land, forest land, and then carbon footprint. So why does this matter? Canadians use environmental resources in all areas of their lives. We need to ensure we are using only as many resources as our environment is able to sustainably provide. Otherwise, we may find that the resources needed for our food, for our shelter, work, and leisure activities may no longer be available. While Canada still exceeds its biocapacity over its overall ecological footprint, like all countries, we must be aware of our carbon footprint if we want to keep that reality a consistent reality. The charts to the right here shows cities with the highest carbon footprint. Does it kind of surprise you which cities at number 1 here? Calgary produces more carbon dioxide per person in an urban setting than even some of the smog-filled city of Mexico City or New York City itself, according to a report by the United Nations. Going by new international measuring standards, Calgary produces 17.7 tons of carbon dioxide per capita, ranking it 5th highest in a comparison of 50 global cities. Why do you think that is? Toronto and Vancouver, the only other Canadian cities surveyed, had emissions of 9.5 tons and 4.9 tons respectively. That brings them near the middle of the pack along with Tokyo and Mexico City. The electrical grids in those cities run on nuclear power, whereas Calgary relies on coal-fired electrical plants that create more emissions. Calgarians get their power from burning coal. They live in a fairly sprawling city, and because we have large homes and we really have no climate regulations in Canada, it's not surprising at all, said Chris Severson-Baker of the Pembina Institute in Alberta. So every time they turn on the lights, they turn on their TV, they're essentially burning coal due to that power plant, and that is a significant source of greenhouse gas emissions and something that we could do a lot of work on to reduce. It's not an easy task though, because you're essentially asking the entire city to convert from coal-fired electrical plants to something more green, such as a nuclear power plant or, hydropower, solar power, so on. That requires lots and lots and lots of money. But does that make it not worthwhile? Calgary also has a high reliance on automobiles. Amenities are pretty spread far apart, and the lack of public transit leave few choices in getting around. The UN Environment Program report was prepared for last month's World Urban Forum. Only Washington, D.C., Minneapolis, Denver, and Rotterdam, Netherlands produced more carbon dioxide than Calgary, according to that study. So I got a quick little video here for you.
More than 80% of people in the world today live in countries that demand more from nature than their ecosystems can regenerate. Their countries' ecological budgets are in the red. We know this from ecological footprint accounting. The ecological footprint measures human demand on nature and can be compared to biocapacity, which is the productivity of a region's ecological assets. China has the largest total ecological footprint, making up nearly 24% of the world's total ecological footprint. However, China's footprint per person is only 3.6 global hectares. By comparison, the footprint per person of the United States is much larger at 8.6 global hectares. Brazil, meanwhile, has an ecological reserve thanks to its immense forests. Brazil has a biocapacity per person of nearly 8.9 global hectares and a footprint per person of 3 global hectares. Carbon emissions are the largest component of the ecological footprint. The footprint also includes consumption of food, timber, fiber such as cotton, and use of land for cities. Global Footprint Network calculates the footprint of more than 200 countries and regions from 1961 to the present. Find out if your country's ecological budget is in the red. Visit our Footprint Explorer open data platform at data.footprintnetwork.org.
All right. Across Canada, the Federation of Canadian Municipalities, the FCM, reported a wide range of footprints in municipalities from a low of 6.87 hectares per capita in Greater Sudbury to a high of 9.86 hectares for Calgary, which, considering the last couple slides, shouldn't be very surprising. Peel's ecological footprint is 7.83 hectares per capita and is the sixth highest in Canada behind Calgary, Edmonton, Halton, Ottawa, and York. For Peel, this represents 108% of the Canadian average ecological footprint, which, if you keep in mind, was more in the eights. In general, municipalities with larger footprints have higher household incomes and higher fossil fuel-based energy consumption. Basically boils down to that the people in the richer areas are just consuming more, which probably is not much of a surprise. Peel scored well in the built area category and is listed as having one of the lowest per capita built area footprints of the regions in municipalities that were measured. Built area is based on provincial urban land use and infrastructure data and is the land area used to accommodate homes, roads, utilities, industry, and hydroelectric energy generation. So as I mentioned earlier, there are 6 general types of land surfaces that are considered for the ecological footprint. You have cropland, grazing land, fishing grounds, built-up land, forest area, and then the carbon demand on land. Each of these types you can kind of assume what their purposes are. Something like cropland is used for the crops that we consume, such as corn, grazing land for, cattle, and then so on and so on. If a population's ecological footprint exceeds the region's biocapacity, as I mentioned earlier, that region runs an ecological deficit. Its demand for the goods and services that its land and seas can provide, so the fruits and vegetables, meat, fish, wood, cotton for clothing, and carbon dioxide absorption, exceeds what the region's ecosystems can renew. A region in ecological deficit meets demand by importing, liquidating its own ecological assets, such as overfishing, which, as you can imagine, is not recommended, and or emitting carbon dioxide into the atmosphere. If a region's biocapacity exceeds its ecological footprint, so the opposite, this is the preferred outcome, it has an ecological reserve. So let's talk about those 6 types of land types, shall we? First up, we have cropland. New farming techniques and studies on sustainability are causing countries to be more aware of the use of the land they designate for crops worldwide. Constant awareness to the yield of a crop is the main concern of a farmer. Genetically altering of seed has become commonplace in order to maximize yield per acre along with rotating crops and fertilization. This gets into GMOs a little bit, but it is an important thing that we can discuss. There must always be a constant concern that clearing land of forest in order to open more cropland has its implications. All areas of the world are connected throughout life support system. The Earth's supply of air, water, and other resources that we all need. What happens on land in one area can affect other parts of the world through connections within this system. By destroying forest, for instance, to create more cropland, it reduces our ability to fixate carbon, it destroys habitats, and it just removes possible sources that can produce oxygen for us to breathe. What happens on land in one area can affect other parts of the world through connections within this system. Here's an example. In China, eroded lands form part of a massive cloud of pollutants, which is called the Asian brown cloud, that stretches over much of Asia. It affects the air, water, and land of this vast area. In fact, satellites have tracked the spread of long-lived pollutants in this cloud from northern China across the Pacific Ocean to the west coast of the United States. You can imagine that's a pretty extraordinary feat considering how large the Pacific Ocean is. If anybody's ever flown across it, you know it's an ordeal. Logging and land clearing have other adverse effects on the ecosystem. Although we rely on the building materials and paper from forests, many of the medicines we depend on were derived from tropical forest plants. Our life support system itself depends on the Earth's great variety of plants and animals that live in these land ecosystems. By removing ecosystems, we remove those plants and animals, which removes our ability to collect what we need from them. Land-based ecosystems supply us with vital natural or ecosystem services such as climate control and the natural purification of air and water. As I mentioned, as a carbon sink, dense forests absorb carbon dioxide from the atmosphere by consuming it and converting it into oxygen, which helps reduce atmospheric temperatures from soaring to levels that would drastically change the climate. This change would ruin some areas for farming, endanger certain water supplies, and result in rising sea levels and major flooding in some areas. There are websites that you can go to that actually show projections of rising sea levels and how much flooding we can expect on coastal areas based on current trends. It's quite interesting to see how some cities, such as New York, might be impacted. Grasslands and forests have built up vital, rich topsoil on which farmers depend for producing food crops. Healthy soil and land ecosystems also store and help purify much of the world's drinking water. As more land becomes degraded, these services will be severely strained. Along with the cropland is the grazing land necessary for raising animals. This chart just shows all of the different types of land types that we have. So we've discussed this earlier in an earlier presentation. I think it was in week 2. But you can see that destroying certain areas such as tropical forest or boreal forest to create cropland can negatively impact what we have left. Interestingly, if you destroy there's a thing called desertification where as you destroy certain land types, they will slowly just turn into desert and the desert starts spreading. You can kind of see this happened a long time ago in the Nile with ancient Egypt, which was a very fertile place and didn't look anything like how it looks now. As they continued basically overindulging in the area, it basically turned from a paradise into the desert that you see today. So, grazing land. The grazing land footprint measures the area of grassland used in addition to crop feeds to support livestock. Grazing land comprises all grasslands used to provide feed for animals, including cultivated pastures, as well as wild grasslands and prairies. The human needs in meat, hides, wool, and milk are increased all the time. The increase forced the grazing of animals, pasture lands to be overgrazed. So, as a question, will the improvements in the biocapacity of ecosystems be able to reduce the gap between their supply and their respective human demand? The fishing grounds footprint is calculated based on the annual primary production required to sustain all harvested aquatic species. This primary production requirement is the mass ratio of harvested fish to annual primary production needed to sustain that species. Rising temperatures are changing the physical properties of the oceans and seas. It changes the salinity and the oxygen content. It changes the hydrographical structure and currents, ocean acidification, and of course, as we've discussed and as has been a topic for a while now, sea levels rise. Temperature changes are occurring faster on the continental shelves due to it's a self-feeding mechanism at this point, the very areas where commercially important fish stocks live. Most fish are actually typically found close to continental shelves. Of course, you can do deep sea fishing. It's a thing for a reason, but most fish tend to like to stay closer to the actual edges of the ocean, if you will, because first off, that's where sunlight and more resources are found, such as plant and kelp that they eat. And then if they are predators, that's where their prey will be found too. If you were to look at a population density, I guess, of fish throughout the ocean, the vast majority of it would be found along the peripherals around the continental shelves and closer to the coast. Changes in these physical properties of the ocean may lead to shifts in abundance and distribution of fish populations, the easier spread of introduced alien species, or the migration of warm water fish species into cold ecosystems. Changes may even lead to the disappearance of a species from an area. Similarly, the impact of acidification on an ecosystem may lead to the death or migration of fish stocks. Climate change may also disrupt marine food chains, which will have serious consequences for the survival and productivity of many fish species. Maybe not as extreme an example as disrupting entire food chains, but a decent example was, I forget which year this happened, so if you're curious, you can look this up. But back in the day, the St. Lawrence River, as you can imagine, was a major source of cargo being shipped in. So they actually created a canal to allow ships to be, brought from the St. Lawrence River to the Great Lakes. But this had the unintended consequence of introducing sea lamprey to the Great Lakes. Sea lamprey themselves were doing fine in the seas or the St. Lawrence River, but once introduced into the lakes, they became an invasive species that essentially destroyed fish populations. There's been tons of research done on how to reduce sea lamprey populations because they're a parasite that basically latch onto the side of fish and just suck their blood. I both do and don't recommend you look up a picture of them because they're kind of hideous alien looking creatures. And what ends up happening is even if the fish survives the initial sea lamprey attaching to them, the wound that's created can oftentimes get infected or just make the animal weak enough that they can't escape and they just die slowly. So this is just an example of the introduction of one species can drastically impact the productivity of other species. These climate change related impacts will place substantial additional pressure on fish stocks, which are already heavily stressed by overfishing. Overfishing is a constant problem. More than 80% of European fish stocks are currently overfished and are, as a consequence, less resilient to climate impacts. Why is that? As you continue to overfish a population, you, as you can imagine, drastically decrease their population, and with a smaller population, any loss to it is that much more drastic, right? If they lose those members of their society, or society seems a bit of a stretch for a fish population, but lose those members from their population, then those genes, that DNA is permanently lost. So you lose genetic variability as well, which is a big problem. This will have severe economic implications for fisheries as well. So Europe is constantly trying to make less of a footprint in their fishing grounds. So there have been many studies done. There's the Norway lobster fishery. The fuel needed to catch and land a kilo of Norway lobster can be reduced from 9 liters to 2.2 liters by switching from conventional trawl fisheries to creel fisheries. Such a switch would also significantly reduce the bycatch of non-target species and impacts on the seabed and provide the consumer with a Norway lobster that hasn't been squashed in a trawler's net and is thus of a better quality too. The Danish flatfish fishery, the amount of fuel per kilogram of caught fish could be reduced by a factor of 15 by switching from beam trawling to the Danish seine. Danish seine is a semi-passive fishery which has less impact on the seabed than beam trawling. And then finally, for the Swedish cod fishery, Swedish cod is caught both in trawls and with gill nets. During trawling, over 4 times more fuel is used per kilogram landing cod than during gill net fishing. So just these small changes can drastically decrease the amount of a footprint that's used to catch these fish, which is obviously a good thing and hopefully stuff that is implemented. Sometimes this stuff takes a while just due to human nature to prevent change or not work with change well, but also it shows our capacity to learn and develop new techniques to make things more efficient. Fuel use and consequently greenhouse gas emissions that emit from the use of fuel varies considerably depending on the fishery. Fishing on depleted fish stocks requires more fuel per kilo landed fish than fishing in abundant fish stocks, just because the fishers have to search longer. That just makes sense. They have to look around more in order to find the fish they're searching for, which consumes more gas. It also uses heavier gear to catch the fish. If fish stocks were allowed to recover, less fuel would be needed to catch the same amount of fish because there'd be a larger population and therefore a greater chance of finding them. In addition, enhancing fish abundance will allow fish populations to become more resilient to the impacts of climate change, which is by introducing more genetic variation. And then there's the built-up land. It's one of the least to impact our ecological footprint. As you can see from the chart provided, it doesn't even make up 1% of the whole. It also includes the land required to absorb emissions from the energy people use and to provide space for its infrastructure, including roads and built areas. People consume resources and ecological services from all over the world, so their footprint is a sum of these areas wherever they may be on the planet. Built-up land footprint is calculated based on the area of land covered by human infrastructure, which includes roads, car parks, houses and buildings, industrial structures, and reservoirs for hydroelectric power generation. In 2008, the built-up land area of the world was approximately 170 million hectares, which seems large, but that's the entire world. The Global Footprint Network assumes that built-up land occupies what would previously have been cropland. This assumption is based on the observation that human settlements are generally situated in fertile areas with the potential for supporting high-yielding cropland. Basically meaning that we like to produce or like to live in, fertile areas, which is not much of a stretch to imagine. And if it wasn't for these built-up lands being here, they would be crops instead. The forest land footprint measures the annual harvest of fuel wood and timber to supply forest products. Worldwide in 2008, there were 4.04 billion hectares of forest land area in the world. When you compare that back to 170 million hectares for the built-up land, you can see how large forest is throughout the world. Forests cover 31% of the world's land surface, just over 4 billion hectares. And remember, 1 hectare is 2.47 acres. This is down, however, from the pre-industrial area of 5.9 billion hectares, which might not seem substantial, but when you think how much a billion really is, we're dropping from almost 6 to just over 4 in about, how many years. It's quite a giant drop. The footprint accounts calculate the footprint of forest land according to the production quantities of primary timber products and wood fuel products. Overall, deforestation has been taking place at a pace of about 13 million hectares per year during the period of 1990 to 2005, an area about roughly the size of Greece, with few signs of a decrease over time. Though deforestation continues at an alarming rate, the annual net loss of forest area is decreasing due to tree planting and natural expansion of forests in some countries and regions. Tree planting is a pretty important initiative just for this reason. So we have here, the Ontario government has committed to planting 50 million trees by 2025, and to date, they've helped more than 4,000 landowners get involved. Planting trees is a practical way to get more from your property, give back to the community, and just to help the environment. Everybody likes standing under the shade of a tree too, right? So you can increase the value of your land, you improve the quality of your soil, you increase wildlife habitat, you enhance recreational opportunities, and you improve the overall health of the environment and leave a lasting legacy. There's almost zero negative side effects to just planting trees. This actual commitment that the government has put in has also said that they'll cover up to 90% of the total costs through subsidies, and you could even realize a savings on your property taxes if you plant 10 acres of trees or increase the size of your existing forest to more than 10 acres and become eligible to participate in the government's managed forest tax incentive program. If you want to find out more, you can go to the website shown there, www.forestsontario.ca. This is pretty much the same slide as before. Not sure why that's there. So the carbon footprint, it's the carbon demand on the land, measures the carbon dioxide emissions associated with fossil fuel use. In ecological footprint accounts, these amounts are converted into biologically productive areas necessary for absorbing this carbon dioxide. The carbon footprint is added to the ecological footprint because it is a global competing use of bioproductive space, since increasing carbon dioxide concentrations in the atmosphere is considered to represent a buildup of ecological debt by higher developed countries. For example, Calgary's carbon footprint, which is due to the coal power plants, the vehicles they drive, and so on and so on. Some carbon footprint assessments express results in tons released per year without translating this amount into area needed to counteract it. Biocapacity is usually described in hectares, whereas carbon footprint is usually in tons of emissions. The carbon footprint is a subject of discussion on its own and will be detailed further in a later lecture. Vehicle and fuel fire generators contribute largely to the carbon footprint. Since land is able to absorb the uptake of carbon dioxide globally, reforestation and limiting deforestation seems to be the only long-term solution at the moment. Unless there's some miracle technology we develop, reforestation is a fantastic way to increase how much carbon dioxide can be absorbed. So to conclude with this presentation, the ecological footprint is well known as people become more aware of the impact they have on the planet, not just in their own country. Carbon dioxide emissions are a constant concern. We even have signs of no idle zone in most shopping malls, just in a way to try and keep our air cleaner. There are many ways of leaving less of a footprint, and this chart shown here shows some of them. Recycling, hanging dry clothes instead of using a dryer, replacing a typical car with a hybrid, and you can even get into more extreme ones like switching to an electric car or just going car-free in general. Eat a plant-based diet, avoid one round-trip transatlantic flight. Those types of things are much higher impacts on the individual way to improve our environment. So that brings us to the end of this presentation. Next week, we will be talking about the oxygen, carbon dioxide, and carbon cycles. Another reminder that assignment number 2, the Fighting Climate Change, will be due February 11th at midnight. And one final reminder that assignment 1 on the the carbon footprint will be due tonight at midnight. So February 4th at midnight, it will be due. If you submit it afterwards, it will be a 5% deduction per day. I hope you enjoyed this presentation. I hope you enjoy the virtual escape room and more. As always, you can always leave your feedback through email. You can talk to me on the discussion boards that I produce. There's the office hours coming up. Feel free to reach out to me for anything. I always love interacting with you guys. Until then, I'll see you guys next week, and I hope you guys have a great week.